A blissful afternoon to you, young learners of mathematics. Okay, in our previous episode, we have looked at angles, some of the properties of angles, like angles on a straight line, angles in a right angle triangle, in a right angle, some of angles in a right angle, some of angles at a point. We have looked at that, and we have also looked at how questions can be asked regarding them. So, this lesson, we are going to focus on polygons properly. Okay, so we are going to talk about polygons. And what do we understand by polygons? Polygons are plane shapes. They are just plane shapes naturally. Polygons are plane shapes. Polygons are plane shapes that are bounded by three or more straight lines. Polygons are plane shapes that are bounded by three or more straight lines. They are bounded by three or more straight lines. And when we talk about straight lines, it begins from triangle, three or more straight lines. This is a polygon. This is a three-sided polygon. We can talk about the four-sided polygon. One, two, three, four. There are four sides there. We can talk about the five-sided polygon. One, two, three, four, five. This is a five-sided. We can talk about the six-sided. One, two, three, four, five. Then six. This is a six-sided polygon, and like that, and like that. And they have special names by which they are called. Polygons and their special names. When the number of sides, we have their number of sides and their names. If it is a three-sided polygon, they refer to it as triangle. If it is a four-sided polygon, it is called a quadrilateral. Chord means four. Chord lateral. Lateral means sides. Quadrilateral, that's four sides. And examples are rectangle, square, kite, rhombus, trapezium, parallelogram. We also have a polygon that can be five-sided. It's referred to as pentagon. We have a six-sided polygon. It's referred to as hexagon. We have a seven-sided polygon. It's referred to as heptagon. Heptagon. We have eight-sided. It is called octa. Octa means eight. Octagon. Eight-sided. And we also have our nine-sided is called a nonagon. It's called a nonagon. And we have our 10-sided polygon is called a decagon. It's called a decagon. So having known all of these sides and the special names by which they are called, now let us move into sum of angle in a polygon. Sum of angles, sum of angles, sum of interior angles in a polygon. Interior, we have interior and we have exterior, but let's focus on sum of angles, interior angles of a polygon. Now, the formula for generating sum of angle is given as S refers to as sum is given as open brackets n minus 2 multiplied by 180 degree. Now, we have been told many times that the sum of angle in a triangle is 180. How did they come about that? Don't forget that a triangle is also a polygon, and it is a polygon that has three sides. So let us see whether it's actually going to be 180. So when you insert your n, which is 3, for triangle, 3 minus 2 multiplied by 180 degree. 3 minus 2, that's 1 multiplied by 180 degree. Can you now see why the sum of angle in a triangle is 180? Following this generalization. Now, this is for a triangle. This is for a triangle. That is where they got that sum of angle in a triangle is 180. Let us see some other polygons. Let us see for a quadrilateral. Don't forget, for a quadrilateral, they are four-sided. Why did they say the sum of angle in a rectangle in a square? Why did they say their sum is 360? Let us check. Since the sum of angle in any polygon is given as sum of interior angles is given as open bracket n minus 2 times 180 degree. Now for a quadrilateral, the number of side is 4. That's 4 minus 2 multiplied by 180 degrees. So 4 minus 2, that's 2. 2 multiplied by 180 degree, that will give us 360 degrees. And that is where the generalization that the sum of angle in a rectangle, which is a quadrilateral, is 360. Sum of angle in a square, which is a quadrilateral, is 360. Sum of angle in a trapezium is 360, which is also a quadrilateral. This is where it all came about. Now, let us look at how questions are asked. How questions are asked under polygons. Under polygons. Under polygons. Let us see how questions are being asked. Without boring us, let us take a quick example. Okay, so let's start from a triangle in which we have A degrees, we have 30 degrees here, and we have 60 degrees here. And they ask us to find A. They ask us to find A. Don't forget that before you do anything in a polygon, you have to find the sum of angle. But if you already know the sum of angle, you can go ahead. Don't forget this is a triangle. What is the sum of angle in a triangle? That's 180. That means that when I had everything here, A degree plus 30 degree plus 60 degrees, everything must give me 180. The reason being that sum of angles in a triangle is 180. If you are writing a theory question, it's important that you write those points there. Sum of angles in a triangle is 180. Is 180 degrees. Okay, so as you can see, A is different from 30 and 60. 30 and 60 look alike. We can collect them together. So A plus 90 degrees equals 180. And you have also learned about simple equation. The purpose of learning simple equation is to enable you to be able to solve problems involving equation. This is also like an equation, is an equation. This and this look alike. So let us collect like terms. Let us collect like terms. When we collect like terms, this 90 will come here. A equals, I always emphasize, whatever you meet at home, write it first. 180 degrees minus 90 degrees. So in this case, our A equals 90. So the missing angle in the triangle is what? The value is 90 degrees. Now, let us see another example. Still on that triangle, if you have something like this, I have x degrees, I have 2x degrees, and I have 40 degrees. Okay, I have 50 degrees here. I have 50. And the question says find x and also find 2x degrees. So let us see. This is a triangle. The sum of angle in a triangle is 180. So I have x plus 2x plus 50 degrees. Everything equals 180 degrees. So what is x plus 2x? That's 3x degrees plus 50 degrees equals 150 degrees. So let us also collect like terms. 3x equals 150 degrees minus 50 degrees. So my 3x will give me 100 degree. This is also an equation involving coefficients. What do we do from here? We'll say divide both sides by 3. Divide both sides by 3. That will be 3 multiplied by x over 3 equals 100 degrees over 3. Okay, so in this case, my 3 cancels 3. Let's use another pen. My 3 cancels 3. Equals, sorry, x equals, x equals 100 degrees over 3. And you can you can always divide it. X equals, that's like 33 whole number 1 over 3 degrees. If you convert your 1 over 3, that will be 33.33 degrees. So this is the value of your x. This one is not giving us old number. That's not to say the question is wrong. Your answers can give you old numbers, or you can have something like mixed numbers that you can later convert to decimal. So if x is 33.33, what is the value of 2x? 2x will be 2 multiplied by what my x is 33.3. When you multiply that, you can get whatever your x will be. Maybe that should be like 66.66 degrees, and that's the value of x. Okay, so let us look at another question. Still under polygon. Still under polygon. Let us look at this. I have this beautiful drawing here. I have this. Okay, this place is y. This place is also another y. They call this place y plus 30 degrees. They call this place y plus 20 all degrees. And this place is also called y. The question says find y. So the very first thing you are going to do is to count how many sides that you have. So let us count the sides. 1, 2, 3, 4, 5. This is the 5-sided polygon. So if you don't know what the sum of angle is, you can quickly go and use a formula. Sum of angle for interior angles, n minus 2 times 180 degrees. So since it's 5 minus 2 multiplied by 180, that is 3 multiplied by 180 degrees. And that will give us 540 degrees. That means that the sum of angle here is 540. And I'm going to add everything together. That means that by the time I have everything together inside, let us look at the shape one more time. Look at what the shape looks like. Y plus 20, y plus 20, y plus 30. Okay, so we had it together. We have y plus y plus another y. We have 3y there. Plus y plus 20 all degrees. Then plus y plus 30 all degrees. Everything equals 540 degrees because this is a pentagon. So we had those things that look alike. We have y plus y plus y plus y plus 20 plus y plus 30 degrees. Are we together? Equals 540. Okay, so let's add them together. Y plus y plus y plus y, that is 5y degrees. 20 plus 30 will give us 50, equals 540 degrees. So let's collect like terms. Let the 50 go and make 540. So 5y degree equals 540 degrees minus 50 degrees. So when we do that, we are going to have 5y equals 490 degrees. And we are looking for y. This type of equation, we divide both sides by y, or you can say divide both sides by the coefficient of y. Divide both sides by 5. So what do we have? We have 5 multiplied by y over 5 equals 490 degrees over 5. So 5 cancels 5. Y degree equals 490 degrees over 5. So let us divide. We have y equals 5 goes there 1, 5 goes in 49, that is 9, 45 remainder 4. We put it on 0, 5 goes in 40, that is 8. So the value of our y is 98 degrees. Are we together? So that is how to solve problems involving polygons. So before I go, I will leave you with some exercises which you can play around with. So try to play around with them. If you have any problem, feel free to message me. I'll be willing to hear from you. We have this. We have this. We have this 65. And we have this. So the question says we should find x. Let us find x here. Okay, let us see number 2. We also have this. We 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 have this. Okay, what okay, we have 130 degrees. We have another 130 degrees. We have a 3, this is 130. We have 3x degrees. We have 120. This place is 3x. We also have 140 degrees here. Then on this corner we have x. So the question says we should find x. Let us find x. I want to believe you enjoy the class as much as I also enjoy the class. It's a bye for now.